All right, so let's take a look at some of the different kinds of functions that we could run into in determining where our critical numbers are and where the extrema are located on the intervals. So we've got this function f of x equals 2x plus 5 over 3 on the interval from 0 to 5. Well, all right, we know that written a different way, f of x could actually be expressed as 2/3 x plus 5/3. And we know that that means that we've got this linear function where if we take the derivative, f prime of x is just simply equal to the number 2/3. Well, what does that indicate? Well, in this case, there are no values where we have a critical number interior to the interval, right? So there's no critical numbers here. No critical number. So in that case, how could we identify any maximum or minimums? Well, in this case, because it is a closed interval, we should look at f of a and f of b. Well, all right, f of 0, if we substitute it into our original function right here, is 2 times 0 plus 5. That gives us 5/3. And then we want to look at the endpoint f of 5. What happens at 5? Well, at 5, we're going to get 2 times 5 plus 5. That's 15 over 3, so we get y equals 5. You might want to pause if you want to work that out and verify my numbers. But in this case, 5 is greater than 5/3. Therefore, we're going to have an absolute minimum on this interval at x equals 0, the endpoint. And we're going to have our absolute maximum occur at our endpoint x equals 5. Okay. Now, just a quick note on this one. What would happen if somebody gave you an open interval? What if we said, what if the function were defined? How about f of x on the open interval from 0 to 5, and we had no endpoints right there? Well, if that were the case, it is very possible that we could say that there were no extrema at all. It is possible for a function to be defined on an interval in such a way so that it had no maximum or no minimum. We could get infinitely close to x equals 0 and infinitely close to x equals 5, but unless we define what happens at those endpoints, no extrema. All right, let's take a look at another function right here. We've got the function g of x equals 12x squared minus x cubed. So, of course, we should look for our critical numbers. We're going to find critical numbers at any place where the derivative is either undefined or equal to 0. So our critical numbers here, 12x squared, or 12x, derivative of that is 12. Derivative of x cubed is going to be 3x squared. And so we're looking for any critical numbers on the interval from 0 to 4. So let's set our derivative equal to 0 and see if we can find any points where that occurs. There are no points where the derivative is undefined in this case. Doing that gives us 12 is equal to 3x squared, or stated another way, x squared is equal to 4. And so our values here are going to be x equals plus or minus 2. Well, on the interval from 0 to 4, our critical number is going to occur only at x equals 2. We ignore negative 2 because it's not in the interval. All right. We should then go through and substitute in x equals 2 and see what happens. G of 2 is going to be 12 times 2 minus 2 cubed, which is to say 24 minus 8, which is 16. So G of 2 is 16. All right. Now we should also look at our endpoints. right? So we're going to look at g of 0. G of 0, well, we can work that out pretty well. 12 times 0 minus 0 cubed, that's going to be 0. How about g of 4? All right, well, let's take a look at g of 4. G of 4 is going to be 12 times 4 minus 4 cubed. It doesn't look like we're going to get a 0 here. That's going to be, let's see, 12 times 4, 48 minus 64. That's going to be negative 16. Negative 16. All right, so what we should do right here, we've got, it looks like 3 different values of x, which we're going to have to examine. So what we do is we put those points in order. Our points, our critical numbers that we're examining right here are 0, 2, and 4. The values of g of x for each of those x values are going to be 0, 16, and negative 16. Well, we don't have an absolute maximum at this endpoint, so we ignore it. But right here, it looks like we're going to say there's an absolute maximum located at x equals 2. That's the highest value of g of x that we find anywhere in this function. The absolute minimum in this case is going to occur at x equals 4, because this is the lowest value of g of x that we find anywhere on the interval. And we know there are no other critical numbers at which a maximum or minimum can occur, so we're sure these are the absolute maximum and absolute minimum of the function on the interval.